This is half past paper week 9 foundation, all of the odd numbers. These are all the topics that I will be covering in this paper, and you've got the Sparks codes on the right just in case you are a Sparks school and you've got access to that as well. So question number 1 is to write 0.75 as a fraction, and I find the easiest way to think about this is to say, well, it's 75, but it's been moved 2 place value columns to the right, so 75 divided by 100. And you can simplify that. You might just know that 0.75 is 3/4, so either of those answers would be absolutely fine. The reason we can simplify it is because they're both in the 25 times table, so either of those answers is fine. I'm going to pop 3/4 on the answer line, but you don't need to simplify it. 75 over 100 is absolutely fine. Okay, question number 3, write down 2 factors of 15. So factors fit in. Factors are numbers that fit in an exact number of times. So your factors of 15 are 1 and 15. Always think of them in pairs so you don't forget any. And then 3 and 5. Those are all of the numbers that fit into 15 an exact number of times. Now you do not need to write them all on the answer line. You just need to write 2 of them. I'm going to go for 3 and 5, and they don't even have to both be one that makes a pair. You could write 1 and 5, you could write 3 and 15, it's entirely up to you. Okay, question number 5, write the number 2 million in figures. So with your place value, you've got the ones column, the tens column, the hundreds column, and then you've got the thousands column, 10,000s, 100,000s, and then the millions. So if you want 2 million, it's going to need a 2 in the millions column, and then nothing in any of the other columns. So our answer looks like this, 6 zeros, 2 million looks like that. You can put the commas in if you find it helpful just to space every 3, but you don't have to. Question number 7, there are Y boats on a lake. There are 7 people on each boat. Write an expression in terms of Y for the total number of people in the boats. So an expression, it just means algebra, okay? It's just some algebraic stuff. It might be adding, might be subtracting. In this case, if there are Y boats on the lake and there are 7 people in each boat, they just want to know how many people is that altogether. Now, if you had 3 boats, you would do 3 times 7. If you had 5 boats, you would do 5 times 7. If you had 10 boats, you would do 10 times 7. So the sum that we would do is a multiplication of however many boats there are multiplied by the 7 people. So I don't know how many boats there are, but I do know that there are Y boats. So it's going to be Y times 7. I'm not going to write it like that though. How do I write Y times 7? I write 7Y, 7 lots of Y. That would be your answer for 1 mark. Question number 9, and we've got a pictogram, a really common question on the foundation paper. The pictogram shows information about the number of vinyl records sold in a shop on Monday and on Tuesday. And we've got the key over here that says that this is worth 8. So I've got 8, 8 and 8. This is 8, this is 8, and this is a quarter of 8. So if you imagine this shape would be worth 4, then this shape is worth 2. It's a quarter of 8. Okay, so that is that. It says, write down the number of vinyl records sold on Monday. Well, on Monday, we can see we've got 8 add 8 add 8, or 8 times 3, which is 24. What about on Tuesday? Well, on Tuesday, I've got 8 add 8 add 2. So that is 18 altogether. So let's pop that there. 1 mark for each of those. It then says on Wednesday and Thursday, a total of 36 were sold. So I know that between Wednesday and Thursday, it needs to add up to 36. The number of records sold on Thursday was 8 times the number of records sold on Wednesday. Now that is something they like to do a lot, this skill, where this one has to be 8 times this one. So whatever Wednesday is, I'm going to call it X, and Thursday is 8X. Or you can think of it as being in the ratio 1 to 8. So this number has to be 8 times bigger. Now, altogether, that makes 9 parts. So I need to take the 36 and divide it into 9 equal parts, because one of those parts is going to go on Wednesday and 8 of them are going to go on Thursday, and that makes Thursday 8 times bigger. So 36 divided by 9 is 4. So that means that Wednesday needs to equal 4, and Thursday is 8 times bigger, which is 32, and therefore they then add up to make 36. So if you ever get something is 8 times bigger than something, then you're actually dividing by 9. If I said Thursday was 5 times bigger than Wednesday, you'd be dividing by 6. So you just need to include that 1 when you're dividing. Okay, now we've got to draw it. So we've got to complete the pictogram. I know that 4 is half of a circle, a semicircle like that. And for Thursday, I've got to do 32. So I've got 8, 16, 24. Now, another one is going to get us 32. So there we go, we're all there. 8 times 4 is 32. So that's all good. 8, 16, 24, 32. All good. Completed it. There we go. 5 marks in total for that one. Question number 11. P equals 7R, add 3Q. Work out the value of P when R is 5 and Q is minus 4. So we know that P is 7 lots of R. Add 3 lots of Q. That's what that tells us. It's exactly the same as that. So all I'm going to do is I'm going to change this R to be 5 and I'm going to change this Q to be minus 4. So P is 7 lots of 5 and 3 lots of minus 4. Now 7 times 5 is 35 and 3 times minus 4 is minus 12. Now, when you add minus 12, you don't need the brackets there, but if you add minus 12, it's the same as subtracting 12. So 35 take away 12 is 23 as your answer. That topic is substitution with negatives. Again, comes up a lot. I think I'm doing that, doing that question quite a lot when I'm doing papers. Question number 13. The diagram shows 9 identical squares inside a rectangle. The length of the rectangle is 12. And we've got to work out the width. Okay, so all of these squares are identical. Now I can see that if I filled this out like it was if I made this into a grid, you can see that you would fit 1, 2, 3, 4, 5, 6 of them going across. And since all of these squares are identical, I can do 12 divided by 6, and that tells me that each of these little squares is 2 centimetres wide. And because they're squares, if they're 2 centimetres wide, they're also 2 centimetres tall. So there we go, 2 by 2. The width of the rectangle then, well, let's fill this out again. I can see that it would be 2, 2, 2, 2, 2. So 2 times 5 is 10. 10 centimetres for the width of the rectangle. 10 is our answer. Ooh. 10 is our answer there. There we go. Question number 15. A garden is in the shape of a rectangle 90 by 60. Flowers are grown in 40% of the garden. Okay, let's just sketch that because you guys know I like a sketch. So 40% flowers and the rest of the garden is grass. So 60% grass. Work out the area of the garden that's grass. Well, let's get the total area. The total area of this rectangle, area of a rectangle is base times height, so 90 times 60. Now this is a calculator paper, so you can just pop that in your calculator if you want, but also could very easily come up on the non-calculator paper. So 9 times 6 is 54, and then we're going to make that 10 times bigger for the 90 and 10 times bigger for the 60, so 5,400 metres squared. Now you could work out 40% and take it off. But I'm just going to go ahead and work out 60% because that's the same and it's going to be a little bit quicker. So I need to do 60% of 5,400. So 10% we would get by dividing by 10. 10% is 540. If I would like 60%, all I then need to do is times that by 6. So 540 multiplied by 6. And again, we've got a calculator, so we could just use a calculator. But here, what I'm going to do is just do it without so that we're practicing for the non-calculator paper as well. So 6 times 0 is 0. 6 times 4 is 24. So 4 carry the 2. And 6 times 5 is 30. Add the 2 is 32. So 3,240 metres squared is going to be grass. Again, if you'd worked out 40% and subtracted it, you would have got the exact same answer. So there we go, 3,240. They've already put the metre squared on the answer line, but always check that because if they haven't, then that is also worth a mark. Question number 17. There are 84 calories in 100 grams of banana and 87 calories in 100 grams of yogurt. Preeti has 60 grams of banana and 150 grams of yogurt for breakfast. Work out the total number of calories in this breakfast. Okay, so if there are 84 calories in 100 grams of banana, but I only want 60 grams of banana. So that is going to be 60 out of 100. So instead of 100, I only want 60 out of 100 of 84 calories. So I want to do that fraction of 84. I only want 60 grams out of 100 times 84. And I'm just going to type that in my calculator. For the yogurt, again, there is 100 grams of yogurt, and that's 87 calories, but I'm actually putting more. I'm doing 150 out of 100 times by 87. So I want that fraction times 87. That's just one way of doing it, guys. There's lots and lots of different ways of doing it. So as long as you get the same answer here, it doesn't matter. 60 out of 100 times 84, that gets me 50.4 calories from the banana. And for the next one, for the yogurt, I've got 150 out of 100 times by 87, which makes sense because it's going to be more than 87, isn't it? And that is 130.5. I'm then going to add those two answers together to get the total number of calories in this breakfast, 50.4, and that is 180.9 calories. That would be your answer. So another way of doing that would be to break it down to a smaller number that you find helpful. So for example, if the 100 grams of banana is 84 calories, then you might say, well, I know that 20 grams of banana, I'm dividing by 5. I can divide the other side by 5 as well. And the reason I'm getting 20 grams is because we want to get to 60 grams of banana. So you could then times by 3. So if you divided by 5, you'd get 20 grams. So 84 divided by 5, that is 16.8. So there's 16.8 calories in each 20 grams. And then you can times that by 3. And you do get 50.4, exactly the same. So lots of different ways you can do it. Ultimately, you're just working with proportion there, but your answer should end up being 180.9. So well done if you got that. Question number 19. Here is a plan of a kitchen drawn to a scale of 1 to 30. So this means that real life is 30 times bigger than our drawing. So real life is 30 times bigger. Sam is going to put a small table in the kitchen. The table has to be more than 180 centimetres from A and more than 150 centimetres from BC. Show by shading on the diagram the region where Sam can put the table. So this is going to be a little bit tricky for me to do on my iPad and it might not be accurate, but hopefully I can explain to you how to do it. Now, if I want to go more than 180 centimetres from A, from here, that's in real life. So on my drawing, I need to divide that by 30. So 180 divided by 30 is 6. So if it's 180 centimetres away in real life, it's only 6 centimetres away on our drawing. What you would then do is get your compass and you'd open it up so it's 6 centimetres wide. So that, watch my terrible drawing of a compass now, that thing with your pencil on it, there we go, and you'd open it up, hold it against a ruler to make sure that it's 6 centimetres wide. You'd then put the stabby bit here on A and open it up, and then you're going to draw 6 centimetres. I've got no idea how big this is because I'm doing it on my iPad, but I'm just going to roughly do it. So I would say something like that. It's going to make a quarter circle 6 centimetres away from A. Okay, that's how big that would be. Something like that. Yours might be slightly different. I don't know because I'm doing it not to scale. And then more than 150 centimetres from BC. So this is 150 centimetres from, well, this is BC. If we want to go 150 centimetres from that in real life, again, I need to divide that by 30 to find out how far away to go on the drawing. 150 divided by 30 is 5 centimetres. So again, I'm going to get my ruler and I'm going to measure 5 centimetres along from C going this way. So make sure this is 5 centimetres and also 5 centimetres at the top here like this, and then get my ruler and join it up. Is that a ruler or is it an arrow? Let's see. Let's do a line and join it up like that. And then what it says is that it has to be more than 5 centimetres from BC. So we want it to be outside that green line and also more than 180 centimetres from A. And then show by shading the region where Sam can put the table. So Sam can put the table in this bit here, and that's more than enough from both places. Quite tricky, that one. That's called loci and construction, if you're looking for the name of that topic. Loci and construction. Yeah, easier without doing it on the iPad, but hopefully that made sense. Okay, question 21. On the grid below, draw the graph of y equals 2x minus 3 for values of x from minus 2 to 4. So for this, we're going to do a table of values. X goes on the top, y goes on the bottom. And I want to do values of x from minus 2 to 4. So that tells you that alongside x, we need to go minus 2, minus 1, 0, 1, 2, 3, 4. And then this is the rule. It says to get y, you need to do 2 lots of x, take away an extra 3. So I'm going to do 2 lots of x. So I'm going to start with this one. 2 lots of minus 2 is minus 4. Take away another 3 is minus 7. And then I'm going to do 2 lots of minus 1, which is minus 2. Take away another 3 is minus 5. Then I'm going to do 2 lots of 0. 2 lots of 0 is 0. Take away 3 is minus 3. 2 lots of 1 is 2. Take away 3 is minus 1. 2 lots of 2 is 4. Take away 3 is 1. 2 lots of 3 is 6. Take away 3 is 3. And 2 lots of 4 is 8, take away 3 is 5. So we're just substituting each of those x values into that equation, timesing it by 2, taking away 3 to find out what y is. And now each of these is a coordinate that lies on the line. So minus 2 minus 7, that's down here. Minus 1 minus 5, that's there. 0 minus 3 is there. 1 minus 1 is there. 2, 1 is here, 3, 3 is here, and 4, 5 is here. And then we're just going to join that up with a nice straight line going through all of those points. And that is the line y equals 2x minus 3. Some of you may also know that there are 2 pieces of information here. The gradient is 2, the steepness is 2, we're going up in 2s. That's the number in front of the x. And the other number is called your y-intercept, and that is just where it crosses the y-axis. So you might use that to help you as well. But there we go, 4 marks usually for that. Oh, only 3 marks on that one. Outrageous. We'll take it though. Okay, question number 23. A container is in the shape of a cuboid. The container is 2/3 full of water. A cup holds 275 millilitres of water. What's the greatest number of cups that can be completely filled with water from the container? So to get the volume of a cuboid, we do base times width times height. Basically 30 times 6 times 19. So if I'm multiplying that together, 30 times 6 times 19. Again, I'm using my calculator because this is a calculator paper. 3,420 centimetres cubed. But the lovely thing about centimetres cubed is that that is the same as millilitres. So that's also 3,420 millilitres. Now, this is not full. It's only 2/3 full. So I now need to do 2/3 of 3,420. Now, remember, when we find a fraction of a number, you divide by the bottom and then times that by the top. So 3,420 divided by 3 is 1,140, then times that by 2, and that is 2,280 millilitres. So that's how much liquid we've got in the container, and we're now going to share that into 275 millilitre cups to see how many we can completely fill. Now, if we're sharing it into cups, we know that that means we need to divide. So 2,280 divided by 275 is going to be 8.290, and the 9 and the 0 are recurring. Now, even if that was 8.8, we wouldn't round it up because it's saying how many cups can we completely fill with water. And so it's just going to be the whole number part. So 8 cups would be your final answer. If you wrote 8.29 on the answer line, you are going to lose marks there because it said what's the greatest number of cups that can be completely filled. And that's just going to be 8 with no remainder left over. We want them to be completely filled up. Okay, question number 25. Sally used her calculator to work out the value of a number y. The answer on her calculator began 8.3 something, we don't know. Okay, complete the error interval. So imagine you just can't see the numbers that are coming next. With an error interval, it's asking you what is the absolute smallest that the number could have been, and we're going to put that there, and what is the absolute biggest that the number could have been. So the smallest it could have been is 8.30. It could have been that behind that squiggle there is just nothing. It's either a 0 or it's blank. That's what's next. So 8.3 is the absolute smallest it could have been. And the biggest it could be is 8.3999999. So 9 recurring. Okay, that is the absolute biggest it could be. But because 9 recurring is so infinitely close, it's basically 8.4, we just say it's 8.4, and that's why at this top end it's not equal to. It can't actually be 8.4, otherwise we would have seen a 4 here, but it can go so infinitely close to it that we just say it's 8.4, but we say that it's not equal to that. It's just everything up to that. So 8.3 and 8.4, and that's called truncating. It comes up occasionally. Normally when we see that topic, it's rounding, but truncating is 8.3 and then one above, normally 8.4. Question number 27, write 0.00562 in standard form. So standard form is when we have the digits written between 1 and 10. So in this case, 562, I'm going to write 5.62 because it has to be between 1 and 10, times 10 to the power of something. Now it's always times 10, even if it's a really, really small number where clearly we're dividing by 10, or if it's a really, really big number like 5,620,000 or whatever, we're always going to put times 10. And then if you've got a really, really small number like you do here, the power is negative. If you've got a really, really big number, then the power is positive. So in this case, we've got a really small number. That power is going to be negative. How many times would I be dividing by 10 to get from this to what we have here, this? So that's going to be divide by 10, divide by 10, divide by 10. That 5 has gone from being in the ones column to being in the thousandths column. And so we are going to say that's times 10 to the power of minus 3. The number of zeros does always match up on the negative ones, but not on the positive. So never rely on that too much. Okay, and then part B, write 1.452 times 10 to the power of 3 is an ordinary number. So this means times it by 10, times it by 10, times it by 10. So if I times it by 10 once, I'm going to get 14.52. If I times it by 10 again, I'm going to get 145.2. And if I times it by 10 again, 1,452. 1452. So that is it as an ordinary number. This is in standard form. Okay, and last question on this paper, question number 29. A is the vector 4, 5. Now remember, with a vector, your top number is left and right, and your bottom number is up and, your top number is left and right, negative for left, positive for right, and your bottom number is up and down, positive for up, negative for down. So 4, 5 is moving 4 to the right and 5 up. And the vector B here is moving 3 right and 2 up. That's what the vectors do. Now we want to do 4, 5, take away 2 of B. So take away 2 of these. So that's going to be the same as saying 4, 5 minus 6, 4, because I've just doubled each of these. Vectors are not like fractions, so you don't need to worry about the denominators being the same or anything like that. It's not a numerator and a denominator. It's just saying we're going 4 to the right and then we're taking away 6, which means we actually end up going back the other way. So 4 take away 6, that's minus 2, and 5 take away 4, that is just positive 1. So your final answer for that one is minus 2, 1, which means if you did this and then you subtracted or did the opposite of 2 of these, you'd end up going 2 to the left and 1 up overall. That's called the resultant vector. There we go. It wasn't out of 80. It was 39, I think, if I look back at the beginning. I hope you found that helpful. Please check in next week to see week 10.